Hi, I'm Saiful Siddique. I'm a senior in mechanical engineering at University of Michigan Flint. And
I'm his research partner, Aaron Wagel. I'm also a senior in mechanical engineering here at UM-Flint. And this is our subsonic wind tunnel. It's a low-speed wind tunnel, and we're about to demonstrate how it works.
yeah,
If you would.
connectors, electric power.
Told you to start.
We can explain like how it works. Here we see there is no backflow here. Here goes straight.
And you see it's generating enough force to move this vehicle around inside the chamber. Now, if you wanted to know exactly what those forces were, we could put a force sensor or a scale that measures it like grams or pounds or whatever, and we can see how much the wind is actually pushing on. As you can see, this is about a 3-pound model, and it's easily pushing it around.
Right. This is our 16 band manometer here. We collect the data, static pressure in our test chamber, starting point and the finishing point. We got 16 points. We got the pressure inside. Then we got the velocity profile and pressure profile.
So now, do you estimate how long it takes for it to be pushed across, or like the initial burst, of course, made it move, and then it looks like it's moving little by little thereafter.
Yeah, you would really want it to be stationary, and you would just measure that with sensors.
Okay.
The fact that it's moving, the fact that it's moving just shows that there is extraordinary force.
Yes. Yeah.
And here
It would be hard to speak about exactly.
Right.
What force is going on, but you just want to measure it.
But are your expectations like the initial force moves it a lot, and then it moves maybe gradually thereafter?
Yeah, I would estimate that the pressure we would expect for our design speed of 86 miles an hour would be enough to create the movement you're seeing right now.
Okay. Yeah.
This is about like a 3-pound model, and with the angularity of the surfaces and whatnot, we'd expect about 5 pounds of pressure due to the wind inside this chamber. So yeah, it's obviously enough to move it around. And as you can see, it's moving faster because the side is increasing.
Right.
You want to shut it off before it tumbles down the end. And as you can see, how the string slowly settles down, comes to a rest.
Yes, so it's interesting to like have the initial burst, then see the process go, and then to see it wind down.
Yes, absolutely. From the string you can get a visual estimate of the intensity of turbulence within the chamber, which should be at a minimum. Optimally, you want it about 0.1 intensity.
Yes.
And as you can see, our string was not wobbling or moving with vigor. So we have to take more data, but we seem to be pretty close to that.
Yeah. All right.
It seems to be wobbling less than 0.1%.
0.1 is that turbulence intensity. We design our project. We explained like this is a unique project only because of we use something different than other class, which is used in now all around. This is our scheme.
Yes.
It's important to have a removable screen because as tremendous volumes of air will be pushed through here, things like dust, insect particles will tend to clog up these little pores. So if they're not removable, there's considerable disassembly. And any clogging will affect performance.
Right. Sure.
So we made them removable also so that if somebody wanted to try something other than the ideal perforated plate, they could make a new element and slide that in there and see how that affects what goes on in the chamber.
Right. Okay.
This is also for further study. If anybody want to see how it's going.
Yes.
And also we use here honeycomb. This is 3-layer honeycomb
Okay.
to make our air straight.
Right. All right. And then on the other end, the wind goes through.
Yeah,
Yes, it's pulled through with an exhaust fan.
Okay.
And this is about a 5,000 CFM
Yes.
exhaust fan with about a half-horse motor. It turns at about 1,000 RPM under ideal conditions here. And the idea is to suck the air through the device as to eliminate pressure fluctuations from having a blade pump
Okay.
the air through.
Yeah.
So that's why we have it, pointing out instead of pushing in.
Okay, good. Right.
And we want to show something new here. We use that band only for remove the vibration. This is really nice engineering. Here we can remove the vibration, so we use that band. So here and here.
Okay, good. Yeah.
Yeah, it's actually on its own suspension.
And we can also make it level if we want. All are easy to level, and also we also do the same thing here. There's a wheel here and also the adjustable things.
Now, did it take you like most of the semester to put this project together, or?
Yeah, we've been working on it. We started from 0 in January.
Okay, that's
So-
good. Yeah.
So yeah, the design process, and then some of the components that we could order, like the honeycomb
Right.
elements at the front, they took like 3 months to even get. Once we
Okay,
figured
yeah.
out what we needed.
Right.
The overall design probably took a month to
Yeah.
make sure we had everything right, and we could back up our, validate our angles.
Right. Fantastic.
And everything like that. But building it, yeah, it was just the two of us. So our quote I like to throw around is, "There's no wind tunnel store." So
Yeah. Exactly.
so we had to build everything ourselves. But just the two of us, we did it in about what was it, 8 months.
Yeah,
Okay.
it's January to August, straightly 8 months.
Yes. All right.
And good things is here, there are no old design. We designed it and we manufactured it. That's why everything is new to us. So everything takes more time to research on it, how it works, and then we verified on through our journal paper, whatever we have, and then we just make sure our own work. And now we show that our own really works nicely.
Well, all right. Well, congratulations for a successful project.
Thank you very much.
We're very proud of you and the fact that we have a research program here for students who can have accomplishments like this, and hopefully it helps us, but also it'll help you in your career steps as well.
Oh yeah, absolutely. It's an opportunity like no other, I believe.
Yeah. And what's going to happen to this? Are you going to eventually